So Ethereum's main innovation, I guess, as we've heard from other speakers today, is that it's, for the first time, it makes available a general purpose programming language in a fully decentralized environment on a blockchain. And that, by itself, that's kind of, an abstract thing. So why would you want that? And if you're like me, then a lot of times the easiest way to learn a new concept like that is just to see an example of it. So what are people actually using this for? Why would you want to put a program on a decentralized network? What would it do? So at this point, there's dozens, actually, I think hundreds now, of Ethereum applications that are either released or in development. I'm just going to talk to you about one in particular, which is the project that I work on. It's called Augur. Augur is a prediction market platform. But I guess before I jump into the kind of the nitty-gritty of how Augur works, what that means, that it's a prediction market platform, let me take a step back. And so here's something that I think would be pretty cool. So you guys know Siri, right? What if you could ask Siri about things that hadn't happened yet? For example, say you could ask Siri, Siri, who's going to win the 2016 US presidential election?
Jack, Hillary Clinton is the most likely winner of the 2016 presidential election. She has a 51% chance of winning.
51%. So as you can see, that's a canned answer. That's just a recorded sound clip. But that is the kind of information that you get out of Augur. Right? So this is actually, now this is a partial screenshot taken from the development version of the Augur app. So if you go to this URL, augurdev.firebaseapp.com, you'll find a working version of Augur. And you'll see there's a bunch of markets on there. There's a lot of action. People are, it turns out people are very keen to waste fake money. So we're in beta testing right now. We're in public beta. And I guess I shouldn't touch that. While we're in just test mode, we don't want to ask people to entrust their real money to our, unsecurity audited, and in some ways still unfinished software. So when people sign up for an account, we just give them a certain amount of testnet ether. We're on the Morden testnet, for those of you who know what that is. It basically is just play money, right? It's play money, and you can place bets in these markets, like which U.S. candidate will win the U.S. presidency with this fake money. Let's see. So prediction markets are, what makes prediction markets cool is that they're a very general concept, right? Like I like to give the example of politics, like who's going to win a presidential election, because that's historically has been a big use of prediction markets. If any of you remember the platform InTrade, that was one of the most popular things on it, and that's what it was always in the news for, sort of accurately predicting who was going to win presidential elections. But it can be used for things besides that. Prediction markets, actually, basically any kind of market that doesn't involve trading like a physical good is actually just a specific kind of prediction market. So, I give the example of politics, who's going to win the election. Another example might be who will win the Super Bowl in 2017, or who will win the World Cup. Another example might be a financial market, right? Like, what will IBM's stock price be at the first opening bell of 2017? So there's all kinds of things, will there be an earthquake of magnitude 8 or greater in San Francisco this year? Now, if you live in the San Francisco Bay Area, that might be a pretty good thing to know, right? Like, say you're thinking about buying a house. Is there going to be an earthquake this year? I don't know. That could be a hard piece of information to get at if you're not someone who knows if you're not a seismologist, you're not someone who knows a lot about earthquakes, which I'm not, by the way. And so I actually don't know the probability of there being an earthquake of that magnitude in San Francisco. And I think that's true of pretty much anything, right? If you think about your average person today, if you want like really good predictions, really good forecasting information about just about anything, that information's just not really available to you. I mean, for any price, really. And I think that's a shame. And that's something that Augur is trying to fix. We're trying to make this kind of information available. So now you might be wondering, like, the numbers that I'm showing you on the right here, who will win the Super Bowl in 2017? Okay, it has New England Patriots, 15.8%. Now that number is actually a price. It's the price of basically buying a share of that outcome, right? And so if you buy it at 15.8%, that actually means it's about 16 cents to buy a share. And if the New England Patriots actually end up winning, then when the market closes, that becomes worth $1 per share. And if it does, and if the New England Patriots don't win, then it's 0 cents per share, right? So if you predict right, you make money. If you predict wrong, you lose money. And so you might be wondering, like, why is it that these prices have anything to do with how likely these real-world events are to actually happen? Like, well, why are those two things even related? And it turns out they're related through a concept called the wisdom of the crowd. And basically what the wisdom of the crowd is it's the observation that if you take a large group of people, and they don't have to be experts, but if you take a large group of people and they satisfy certain conditions, we'll talk about in a second, then in many cases they can estimate things more accurately than experts in the field, than a single or even multiple experts in the field. Now, having said that, so it's not just, you can't just take any crowd of people and have them exhibit this sort of emergent behavior. So one thing that you need is your crowd of people has to have a certain diversity of opinion, right? So a bad example of a group of people that you want to get some collective wisdom from would say be if you picked 100 members of a cult, right? Because they're probably all going to have the same beliefs because they're all in the same cult. You have to pick people that are basically independent of each other. And what I mean by that is that if I pick 100 people and there's one guy, Bob, and everybody else just says, well, you know, Bob he's really smart, and so we're pretty just going to do what Bob says, then you actually just have one piece of information. You don't have 100 different pieces of information. So you need sort of 100 different people, and they're all making their own decisions, right? They've all sort of thought about the information. They sort of mulled it over. A third and very important thing is the people have to have incentives to do a good job, right? Like if you think about, say I just was polling people, and I was just saying, who do you think is going to win the presidential election? Well, some people would give, you know, their honest assessment of it. I think a lot of people, and we observe this a lot in the media, instead just they sort of interpret that as meaning like, who do you want to win the presidential election? So they take it as an opportunity to shill for their favorite candidate. And one way that really nicely overcomes that tendency is, you know, even more than wanting to shill for your favorite candidate, people like to make money. And so if you give them an incentive to really try and do a good job, you give them some kind of a reward if they end up being right. You know, it can be a prize, you could have a contest, you could have people place bets. Then you can get very accurate crowdsourced estimates. And the final thing is just aggregation. And all that means is you have to have some intelligent way of collecting the information together. A bunch of people making independent estimates. But, you know, so the example here is what will the high temperature be tomorrow? And say we know that say we know in advance the correct answer will be 70 degrees, right? Sorry, it's Fahrenheit. 21 degrees Celsius. So the correct answer will be 21 degrees. And as long as the people who are, sorry, it's not going to let me play it again, is it? As long as the people who are making the guesses or the estimates are not systematically biased in one way or another, then even if the typical estimate is pretty wide of the mark, then on average, the average estimate can actually be very, very close to the correct answer. And I would show you that if I could play it again. Okay, so I've told you a little bit about sort of like why a prediction market might be able to provide good crowdsourced information. But that's actually only sort of half of the picture of a prediction market. There's two big parts to a prediction market. I'm not going to get too into the weeds here, although I'm happy to if people have questions about it. But the two basic parts to a prediction market are so say there's an event we're interested in. We'll just keep using the presidential election. Will Hillary Clinton win? So the first phase of a prediction market is before the event. So this is now, before the presidential election has happened, and nobody knows who's going to win. Right now, we don't know if Hillary's going to win or not. We might have guesses. We might want to we might have strong opinions about whether we think she will or should win. We might even be willing to put our money where our mouth is, put some money down on if we think she's going to win or not. But these are just forecasts, right? We don't know for sure because it hasn't happened yet. And then there's election day. And then there's after the fact, where it suddenly is trivial to know who won, right? The election hour has already been run, so even if you don't know the answer, it's trivial to look it up on Google, right? It's as trivial as knowing who won the presidential election in 2012, or the US presidential election in 2012. Everybody knows that. Or I should say, everybody here knows that. It's easy for humans out in the world to know things about the world, right? Now, the tricky part is that Ethereum doesn't know about it, not by default, right? Ethereum doesn't know anything about the world. Ethereum it's just this decentralized network, and it only knows what we tell it. So how do we get this piece of information? Let's say say Hillary does win. How do we get the information that Hillary actually won onto the blockchain? Well, there's different ways you can imagine doing it, but the way that we settled on was, in some ways, the simplest, maybe the most obvious way, which is we thought, well, everybody knows the answer, right? So let's just ask people, hey, who actually won the election? And we'll make sure it's always the easiest and most profitable option for them to tell the truth. And that's the second half of the Augur system. And I'm not going to really delve into how that incentive system works, but if you guys would like to know, please ask me. Basically, the very short version is in our system, consensus is truth. And so it's people, after the fact, people report on who actually won the election. Right? And it's sort of like this, the easiest way to think of it is the most common answer is the truth. Right? So the Augur and this particular event resolution model, they're good for situations where whatever the outcome of the event is, whoever actually wins the election, say, that's something that is sort of easily knowable after the fact, right? So there's lots of things. There's a whole bunch of things that don't fall into that category, right? Like anything that has like a value judgment in it. Like, will Hillary Clinton be a good president? Well, I mean, I don't know. There's not going to be like a real clear-cut answer that's opinion-based. Anything that's like a conspiracy theory that's not going to be resolved. That's not a good candidate for this kind of prediction market. It has to be things where the answer is clear-cut after the fact. And it's just easy to find out after the fact. Excuse me. So Augur is decentralized basically just by virtue of being on Ethereum. And it's, to me, I think it's a sort of a canonical example of something that is, it needs to be decentralized, something that doesn't work if it's centralized. And just as sort of a graphical representation of one big problem with a centralized model is that in a centralized model, there's a single point of failure, right? So I'm not the first one to touch on this today, but if you think about a service like, say, Google, like very useful service, right? Serves, I don't know how many billions of people. Even though it serves billions of people, Google would be the red cylinder in this picture, right? So if Google, for some reason, goes away, you know, there's some catastrophic error at Google and its server farm shuts down and can't be brought back up, it doesn't matter that there were billions of users of it and that they would like Google to come back. Because they can't interact directly with one another. They only interact asymmetrically with Google as a server. And because that's the extent of their interaction with it, with Google, if Google is gone, then the service is gone. So the other model, and the one that decentralized networks like Ethereum use, is just peer-to-peer. It's purely peer-to-peer interactions. So decentralized networks they have an enormous amount of resilience, a lot of robustness, right? They will not fail because you've removed a single node from the network. And they're robust in other ways too. For example, so you've heard the word trustless a lot today. And Augur, I think, is a good example of why trustlessness is so important. Because so Augur is actually trustless in two ways. One way is that it has, just by virtue of existing on Ethereum, it has decentralized custody of funds. Right? So that means if you buy into Augur, you're not just putting a bunch of money in a pot and, say, giving it to me and say, don't worry, you can trust me. I'm not going to run off with this. Instead, you're just putting it into the Ethereum network. And, and it's cryptographically secured by the network in the same way that any other Ethereum account is secured. So you don't have to trust us to not raid the piggy bank. The other way in which trustlessness is really important is in the way that events are resolved. So after the fact, if you're betting on who won the election, the answer needs to correspond with reality, right? If it doesn't, the system is basically useless. And it's not just useless, but it would be abusable if it was just, say, us or me picking who actually won after the fact. Now, maybe you couldn't get away with fudging that. There'd be too much public outcry for something like an election, where lots and lots of people bet on it. Everybody knows what the answer is. But there, for other things, you might be able to get away with some fudging, or you might just have someone who's supposed to be giving those answers and isn't doing a good job. Like for real-world prediction markets, there were examples of, those markets just getting it wrong after the fact. They were just resolved incorrectly. In fact, I think I even saw an example, not to wade too much into a controversy, but I think I saw an example this morning of a prediction market that exists now that had resolved the question of whether or not Craig Wright is Satoshi, and they resolved it yes. But we've decentralized both of these aspects. We have decentralized custody of funds, and we have a decentralized event resolution, right? So if you're using Augur, there's no Augur group that's really a part of the picture, apart from developing the software. We don't make the markets. We don't bet in the markets. And we don't resolve the events. We don't hold the funds. We're not doing any of that, right? So it's purely peer-to-peer. I don't want to dig too much into this, but I just wanted to give you a sketch of what Augur and actually just an Ethereum application looks like in terms of the software. So the white box where it says decentralized network, that's Ethereum, right? And you have the sort of poorly illustrated, Ethereum nodes interacting with each other. And then you have other software on top of that. So we have this sort of, we just have like a web front end. So if you use Augur, you don't need to know anything about Ethereum. You don't need to, download a special Ethereum client. You don't need to do anything except go to a website, and you use it in much the same way you would use any other website. And our goal is to just make it to make Ethereum as invisible as possible. Like, you shouldn't be aware that you're doing some unusual decentralized thing, aside from that you're getting these extra security guarantees. And so we have a web front end, and we have basically just this big green box is all of our plumbing. It's all the stuff that connects us to Ethereum. And Ethereum can either be running on your computer, or it can be running on a node that is run by the community, and that people have opened to allow Augur requests and transactions through. And again, if anybody has more questions about that, I'm happy to sort of wade in. So aside from the convenience of building Augur on Ethereum, so it is convenient not having to write our own, say, low-level blockchain and networking code, right? Like most application developers, we want to focus on our business logic, not sort of reinventing the wheel. So that is one appeal of developing on Ethereum. But another really significant one to us is existing in Ethereum's ecosystem. And the way that we benefit from that is, so Augur can be used as a tool by other applications on Ethereum. So I was just talking about how Augur works basically by getting information. It's a tool to get real-world information onto the blockchain, right? And that information can be used by other people on the blockchain, other applications on the blockchain. And so I've drawn just a few potential examples here, right? You could have, say, a politics application, something that just takes these values that are coming out of Augur and then uses them for something. A trivial example would be like, if you actually revived the old in-trade. Another might be sports, right? People like to bet on sports, so an example might be trade sports. And there are finance applications. If you think about financial derivatives, options, there's specific kinds of prediction markets. And similarly, Augur actually can use other services in the Ethereum ecosystem as inputs, right? So I just told you we don't provide sort of active services with Augur, right? Like we don't provide, we don't make markets, we don't provide a login system, but other members of the ecosystem can do that. And and so here are three, actually these are in a way three bad examples because two of them are not strictly Ethereum. But as an account service, we are planning to use Airbits just as a way of letting people register and log in and not just store that information locally the way they do now. Right now, if you log in, you register, everything's just stored in your browser. That's fine, and it's nice because it's decentralized. You don't have to trust. You can do it that way. You don't have to trust anybody, and it's just an Ethereum account. But it'd be more convenient if you could move that between computers, and so we're partnering with Airbits to do that. Another example is storing data. Storing information about the user that isn't available on the blockchain, like profile information, for example. Or storing information that the user might want to access in some more efficient way than having to retrieve it from the blockchain. And we are going to be using IPFS for this. Another example might be a transaction service. A service that you can just submit your transaction to it rather than directly to an Ethereum node. We're talking to EtherCamp about doing that. So just a very high-level roadmap of where we're going. One of the most common questions I get about Augur is, when is it coming out? That's what people want to know. I want to know that too. So basically, what's come before is we had a crowd sale, which ended at the beginning of October. And that crowd sale is, it's a fixed endowment, and it's just for the development of the software. And we started our beta test in March. We're doing a sort of trading overhaul this month. And we think the new system will work a lot more smoothly. We've been trying to do some sort of fancy stuff with what are called market scoring rules. We found out those don't, the usability is not that great in practice, so we're introducing just a regular order book. Over the summer, we're doing some security enhancements for the reporting system, we're testing for the reporting system, and we're doing a formal security audit. And assuming all that goes well, then we'll be launching after that. And this is our team. So I don't know if there's time left, but if there is, I'm happy to take any questions.